Do you think space is silent? Well, it's not. In this video, I'll let you hear the sounds of the largest objects in the universe. They are real sounds captured by NASA and other space agencies, and trust me, they only get more terrifying as we go on. Let's begin. Picture yourself floating far from Earth in the deep black of space. You listen carefully and there's nothing, not a whisper. Out here, space is almost completely silent. Sound is just vibrations moving through something. Air, water, metal, even rock. On Earth, air carries most of the sounds we hear. When you talk, your voice makes the air vibrate, and those vibrations reach someone else's ears. Waves crash on a beach because the air carries the sound from the ocean to you. But in most of space, there's no thick air or water. The few atoms floating around are spread out so far that they can't pass those vibrations along. If you yelled without a helmet, the sound wouldn't go anywhere. It would just stay trapped inside your suit. That's why space seems so quiet. But the story doesn't end there. Some parts of the universe can carry waves we can turn into sound. Take giant galaxy clusters, for example. They're filled with hot gas that stretches for millions of light years. This gas can vibrate, sending pressure waves through space. These waves are far too low for human ears to pick up, sometimes millions of times lower than the lowest note a piano can play. Planets with strong magnetic fields like Earth and Jupiter can also make space sounds. Their magnetic fields trap particles from the sun's solar wind, creating something called plasma waves. They don't sound like much at first, our ears can't hear them directly, but scientists use special instruments to record and shift them into a range we can hear. When you hear these recordings, you're not listening to make-believe. When you hear these recordings, you're not listening to make-believe. You're hearing real data from space turned into sound. It's like opening a secret door and discovering the universe isn't as silent as we thought. I want to pause here for a second to tell you that I recently made a poll in the community tab of this channel to ask the question, what is the best way to listen to these sounds? Over 200 people voted in total darkness. You can try it out by pausing the video, turning off the lights, and continuing to watch this video all the way to the end. I think this will be an amazing experience for you. Let's continue. Now that we know how sound works in space, let's meet some of the biggest things out there and find out what they might sound like when we turn their waves into something we can hear. If you could somehow stand back far enough to see it, this would be the largest structure known in the universe. It's not a single object, but a chain of galaxies linked together by gravity, stretching about 10 billion light years across. That's so big. Light itself takes most of the age of the universe to cross it. It's made up of galaxy superclusters, and inside those you've got hot gas, dark matter, and stars. If such a thing could vibrate, then we could pick up those vibrations, the note it made would be unbelievably deep. We'd have to slow it down millions of times just to hear it. TON 618 is a quasar, a super bright object powered by a black hole, and this one is a heavyweight champion. The black hole at its center is around 66 billion times the mass of our sun. It's so far away that the light we see from it started its journey when dinosaurs were still walking the Earth. Around this black hole is a swirling disk of gas and dust that's heated to incredible temperatures. If the turbulence and magnetic activity in that disk could be heard directly, it would sound like a constant, deep, roaring storm. This cluster is famous because it's one of the few places where astronomers have actually detected real pressure waves in space. These waves come from the supermassive black hole at the cluster's center. The note it produces is about 57 octaves below middle C, way too low for human hearing, but NASA has shifted it into our range so we can hear it. This newly discovered object has the longest known radio jets in the universe, stretching 23 million light years from a central black hole. These jets are streams of charged particles moving near the speed of light, slamming into surrounding space. If the plasma inside them could be turned directly into sound, it might be like hearing an endless, low electric roar. When you put these giants into perspective, it's hard to imagine their scale, and even harder to imagine the kind of sounds they'd make if our ears could pick them up naturally. Luckily, scientists have found ways to bring some of those sounds into our world, which we'll hear in the next part. We've met some of the biggest objects in the universe. Now it's time to actually hear them, or at least the closest thing we can get to their real voices. Every sound you're about to hear is based on real data recorded by telescopes, space probes, or gravitational wave detectors. Let's start with the Perseus galaxy cluster. Its central black hole isn't just sitting there quietly, it's pumping out waves through the surrounding gas. These pressure waves are the slowest, deepest note ever detected from space, about 57 octaves below middle C. That's millions of times lower than the lowest bass note you can play on a piano. NASA took those waves, sped them up, and shifted them into a range our ears can hear. The result? A low, steady vibration that makes you feel like the universe itself is humming in the background. When two black holes collide, they send ripples through the very fabric of space, what we call gravitational waves. These waves stretch and squeeze space itself as they pass. Instruments like LIGO and Virgo can detect them and convert them into sound. The most famous one happened in 2015 when LIGO recorded two black holes spiraling toward each other, merging into one. The sound is quick, a short chirp, but it's incredibly powerful. Those two black holes released more energy in a fraction of a second than all the stars in the universe combined at that moment. This one is still a mystery. In 2006, radio astronomers using a balloon-borne experiment picked up a signal they weren't expecting, a background noise coming from all over the sky. It was 6 times louder than it should have been, and nobody knows exactly what's causing it. It's not the Big Bang's leftover radiation. That's already been mapped. Some scientists think it could be from distant galaxies we can't see yet. Others think it might be something we've never encountered before. Whatever it is, when it's shifted into sound, it becomes a steady hiss, like static, but with a strange, almost layered tone underneath. Each of these recordings started as numbers, measurements of waves, frequencies, and signals. But when we turn them into sound, they give us something we can connect to in a more personal way. Instead of just looking at the universe, we're listening to it. And the more we listen, the more we realize that the universe has a lot to say, even if most of it is too deep, too slow, or too strange for our ears to catch on their own. So how do we actually turn something like light waves, X-rays, or gravitational waves into sound? The process is called sonification, and it's a bit like translating one language into another. First, scientists take the data they collect. It could be the brightness of stars, the position of galaxies, or the energy from a black hole. Then they decide how to represent those numbers as sound. A bright star might become a high note, while a dim one could be a lower note. A sudden flare of energy could become a short, sharp burst of sound. It's not just for fun. Sonification helps astronomers notice patterns they might miss just by looking at graphs or images. Sometimes hearing the data makes certain details stand out in ways the eye can't catch. One of the most famous examples is the Andromeda Galaxy. Scientists took images of it and mapped the positions and brightness of its stars to musical tones. As the sound moves from left to right across the picture, you can hear the galaxy, with star clusters becoming chords and bright central regions producing louder, higher-pitched tones. Sonification can also combine multiple types of data into one sound. For example, with images from the Hubble Space Telescope, X-ray data might be turned into one type of tone, while visible light becomes another. The result is a layered soundscape that's both scientifically accurate and surprisingly musical. Even though we'll never actually hear space with our own ears the way we hear sounds on Earth, these techniques give us the next best thing. They turn the cold numbers of astronomy into something we can feel, something our brains are wired to respond to. And once you hear it, you realize that the universe isn't just something to look at. It's something you can listen to, like a giant, slow-moving symphony playing across billions of light years. We've heard real sounds from the universe, but what about the ones we can only imagine? Let's have some fun and think about what the largest objects might sound like if their size and activity could be turned directly into something we could hear. This is the largest known structure in the universe, stretching about 10 billion light years across. If it could vibrate as a whole, which is just a thought experiment, its note would be so low, it might take millions of years for a single vibration to complete. If we sped that up into our hearing range, it might come across as a massive rolling hum that never seems to end. Around the monster black hole TON 618, gas and dust swirl at incredible speeds, getting hotter than the surface of most stars. If we could hear those turbulent flows and magnetic storms, it might sound like a never-ending low-pitched roar mixed with flashes of higher tones, bursts of energy escaping from the chaos. Imagine plasma streams longer than entire galaxies, shooting out from a black hole at nearly the speed of light. If plasma waves inside those jets were made audible, it could be like hearing a deep electric rumble stretching across the entire sky. A sound so huge you'd feel it more than you'd hear it. Now let's combine those ideas with the real sounds we've heard earlier. The Perseus black hole rumble, the LIGO black hole chirp, the space roar, and the Andromeda melody, all layered together with imagined deep hums, roars, and rumbles. If we could really hear these giants, they might sound something like this. Not just noise, but a chorus of the biggest and most powerful things in existence, playing on a stage as large as the universe itself.